Okay, today we're going to go ahead and find equivalent ratios given the total quantity. Write that I can statement down and take a minute to calculate the unit rates. Okay, let's go ahead and get started. So Micah runs 2 3/4 kilometers in 7.5 minutes. What is Micah's speed in kilometers per minute? So let's go ahead and do that. We have kilometers per means for every one, and that's a ratio word. So that means we want to find out how much kilometers for 1 minute. So that means I'm going to put my kilometers on top, 2 3/4 kilometers. Always write your units because it's a unit rate. And 7.5 minutes goes on the bottom. So I know that to turn this into a unit rate, I'm going to have to divide, so I get a 1 on the bottom. So we'll divide by 7.5 on the bottom, which will give me 1 minute. Up here, I need to do 2 3/4 divided by 7.5, which means I'm going to actually turn these into improper fractions. So I'm going to get 11/4. We're not going to run away from our fractions. And we're going to divide 11/4 by 15/2. Now, if I recall correctly, to divide fractions, I have to keep change flips. So I'm going to keep the first fraction the same. So I have 11/4. Change that to a multiplication sign, and I'm going to change this to 2/15. And I can see here that 4 and 2 have a common factor of 2. So this is going to become a 1. That's going to become a 2. So my answer should actually be 11/30ths of a kilometer is my speed in 1 minute. Let's look at another one. Micah runs 2 3/4 kilometers in 7.5 minutes. How long does it take Micah to run 1 kilometer? Let's go ahead and flip this now. So now they're trying to find out how long, so this is going to be my minutes, does it take to run 1 kilometer. Since I want 1 kilometer to be on the bottom, I'm going to put 7.5 minutes on top. And 2 3/4 kilometers on the bottom. Now I have to turn this into a unit rate, which means my goal over here is going to be get 1 kilometer on the bottom. So I have to divide this by 2 3/4, and that's going to give me 1 kilometer. Now if I divide the top by 2 3/4, because I have to do the same thing, I'm going to turn these both into improper fractions again. So I'm going to get 15/2, and then this one's going to become 11/4. But I know that I'm going to have to keep change flip. So I'm going to keep the first fraction the same, and then I'm going to flip the second fraction, so that becomes 4/11, which I can see 4 and 2 again cancel each other. This one becomes a 1, that becomes a 2. So I'm left with 30/11ths of a minute over 1 kilometer. Yesterday we did our walkabout activity, and we looked at how those are really a flip of the other, or a reciprocal relationship. When we flip the units around, the unit rate also experienced this kind of reciprocal action. We're going to keep going, though, talking about the constant of proportionality. And remember, the constant of proportionality is just the multiplier in the proportional relationship. We also call that the unit rate, the slope, K. It has a lot of names. Circle this equation, though, so you remember the formula to really write an equation for a proportional relationship is found by dividing the dependent variable by the independent variable. That gives us the value of the ratio. So let's look at an actual problem. A group of 6 hikers are preparing for a 1-week trip. All the group's supplies will be carried by the hikers in backpacks. The leader decides that each hiker will carry a backpack that is the same fraction of weight to all the other hikers' weights. This means that the heaviest hiker would carry the heaviest load. The table below shows the weight of each hiker and the weight of the backpack. Complete the table. Find the missing amounts of weight by applying the same value of the ratio to the first two rows. So let's do that. Remind yourself that 1 pound is 16 ounces. So we're going to zoom in a little bit tighter here. So now if I start to look at this, I have to think about how we're going to find the K value. Well, since I know that this is going to be my independent variable and this is my dependent variable, because we said in the problem here that it's going to be a proportional relationship between the hiker's weight and the backpack weight. Well, if I'm going to go ahead and know that my K value is really going to be found by putting my dependent over my independent, I'm going to have to use that to help me here. So let's do that. I'm going to go ahead and put the dependent over the independent to find that. But before we do that, let's actually find the total weight. The total weight would be the combination of these two. So if we do 152 pounds and 4 ounces plus 14 pounds and 8 ounces, we're going to get 166 pounds and 12 ounces. We could also write that another way. We could say that's 166 3/4 of a pound, because part of the challenge in this problem is having all these different units, and we really just want to focus on having this as just pounds. So we know 12 out of 16 is equal to 3/4, which is why here I'm going to say 166 3/4. How about the next one? The next one, we can see 107 pounds for 10 ounces plus 10 pounds and 4 ounces is going to give us 117 and 14 ounces, or 117 and 7/8 of a pound. Now, to go back here, we have to figure out some of these missing values. So we first have to really find out, what did we do to the hiker's weight to get the backpack weight? Well, let's see here. So if we figure this out, I'm going to have 14.5 over 152 1/4. You can go ahead and use your calculator. If I do that, if I do 14.5 over 152 1/4, you get this really ugly decimal, which is why it's helpful if we turn it into a fraction. And we can see that the value of K is equal to 2/21. That means the hiker's weight and the backpack weight is proportional because this is being multiplied by K, which K in this situation would be 2/21. Let's see if that works for this one. What is 107 10/16? So let's plug that into our calculator. Times 2/21. If you plug 107 10/16 times 2/21, so we can say that that's 107 basically and 10/16, or I can say 5/8 times 2 fraction 21. I do find I get 10 1/4 pounds, which 4/16 is the same as 1/4. So we know that's the relationship. So let's use this K value to figure out the rest of the table. If I do 129 and 15 ounces, so remember that this is a fraction 15 out of 16, so we can keep it in terms of pounds. So let's plug that in. 129 fraction ABC, 15 ABC, 16 times 2 ABC, 21. I get 12 3/8 pounds. 12 3/8 pounds. 12 3/8 pounds. So now I'm going to have to add 12 3/8 pounds to this weight, and we'll go ahead and calculate the total weight of the backpack. So if I plug in 129 and 15/16 plus 12 and 3/8. I should calculate that we have 142 and 5/16 of a pound will be the weight of the hiker and the backpack. Let's do that again. If I have a hiker who weighs 68 pounds and 4 ounces, and I use my K value that I found from my first two by taking the dependent and dividing it by the independent, if I use that in every row here, it's going to help me. So let's do that again. 64 and 4/16. 64 ABC 4, ABC 16 times 2 ABC 21. I find out that the hiker's backpack is going to weigh 6.5. Let me check to make sure that's why. 68, I was using 64. 68 and 4/16 times 2/21 gives me 6.5 pounds. So the hiker's backpack, if they weigh 68 pounds and 4 ounces, their backpack should weigh 6.5 pounds. So then when we add those two together, we get that their total should be 74 and 3/4 pounds. Let's keep going. Uh-oh. What if they told us the weight of the backpack? Could we work backwards and figure out the hiker's weight? That's right. If we work backwards, we should just divide by 2/21, 2/21, or multiply by its reciprocal, and that will tell us. So let's go ahead and imagine right now. I know this is in front of it, but let's work backwards. What is 8 and 12/16 times 21/2? We should find that this hiker would weigh 91 and 7/8 pounds. If the hiker weighs 91 and 7/8 pounds, we can add 91 and 7/8 and 8 pounds and 12 ounces to find out their total weight of the two of them together. 91 and 7/8 pounds plus 8 pounds, fraction bar 12, fraction bar 16 will tell me that their combined weight would be 100 and 5/8 pounds. What if they're 10 pounds? Well, if they're 10 pounds here, I again could work backwards and divide by 2/21, which I know is the same as multiplying by the reciprocal. So let's plug that in. 10, this time I'll use my calculator to divide the fraction. 2 divided by 21. I find out that this hiker would weigh exactly 105 pounds. If this hiker weighs 105 pounds and their backpack weighs 10 pounds, I can see that they would weigh 115 combined pounds. And we're not going to do these bottom rows. Good job. Let's take a look at another problem. When a business buys a fast food franchise, it's buying the recipes used at every single restaurant with the same name. For example, all Pizzeria Specialty House restaurants have different owners, but they all must use the same recipes for their pizza, sauce, bread, etc. You are now working at your local Pizzeria Specialty House restaurant. Listed below are the amounts of meat used on one Meat Lover's pizza: a 4th cup of sausage, a 3rd cup of pepperoni, a 6th cup of bacon, an 8th cup of ham, and an 8th cup of meat. What is the total amount of toppings used on one Meat Lover's pizza? Let's see. If I add 1/4 plus 1/3 plus 1/6 plus 1/8 plus 1/8, what does that equal? You're right. It equals 1 cup. The total would be 1 cup. The meat must be mixed using this ratio to ensure that the customers will receive the same great tasting Meat Lover's pizza from every Pizzeria Specialty House restaurant nationwide. The table below shows the 3 orders for the Meat Lover's pizza on Super Bowl Sunday. Using the amounts and total for one pizza given above, fill in every row and column of the table so the mixture always tastes the same. So let's see here. If I'm going to go ahead and do sausage, I know that the sausage in one order is going to be 1 cup total. So the total number of cups of sausage in one order was 1 cup. We don't know how many pizzas that was necessarily, but they're telling us the total amount of sausage used in the first order was 1 cup. I want to make sure that it's proportional for all the other relationships. So if we look here, let's go back up and look how much sausage. The rate of sausage usage is 1/4 of a cup, which right away I can tell they must have used 4 pizzas. So if I do 1/4 times 4, that's going to give me 1 cup of pizza, or 1 cup of sausage, excuse me. In the next one, if we go down underneath here, pepperoni. Well, pepperoni used 3 cups. Well, if they use 3 cups of pepperoni, and I know that there's 1/3 cup of pepperoni to make 1 pizza, so that's kind of my K value here, I need to go ahead and say, wait a second, how many pizzas would you have to make to use 3 cups of pepperoni? Well, their order must have had 9 pizzas in it altogether. So that would be what I would use here for this row. In this row, I can see the bacon used. Let's go back up and look at bacon. If the bacon was 1/6 of a cup, and they made 1 whole cup of bacon, they need 1 whole cup of bacon for order 2. I can see here order 2 must have been 6 pizzas. So far, I know that order 1 had 4 pizzas. Order 2 had 6 pizzas, and order 3, since I used 3 cups of pepperoni and I only need 1/3 of a cup of pepperoni for 1 pizza, then this order had to have 9 pizzas. Now that I know this information, I can fill out the rest of the table. If this order has 4 pizzas and 1/4 of a cup of sausage is needed for 1 pizza, then this order would have 1.5 cups of sausage, and this order would have 9/4 cups of sausage, or 2 1/4 cups of sausage. This one I could see would be 6 pizzas, or 6 1/3 cups. 6/3 is the same as 2 cups. Here they would have 4/3, which is equal to 1 1/3. Bacon used 1/6 of a cup, and since order 2 had 6 pizzas because they used 1 whole cup, I can use that same principle here, multiply that by 4, and I get 4/6. So this used 2/3 of a cup. This pizza right here used 9/6 of a cup, because every pizza uses 1/6 of a cup, and if they ordered 9 pizzas, then this would be 1 3/6, or 1.5 cups. Ham. Let's go back up and check out ham. Ham was 1/8 of a cup. If ham is 1/8 of a cup and they used 1/2, that still makes sense, right? 4 1/8 would make 1/2 a cup. So let's use the same principle here. This one would be 6 1/8, which would be equal to 3/4 of a cup of ham for 6 pizzas. This one would be times 9. 9/8 is the same as 1 1/8 cups. If we look at the beef I know used 1 1/8 cups for 9 pizzas. So if I look up here, it's 1/8 cup of beef for every 1 pizza, which means this was times 9. This one is times 6, like we've been practicing. 6/8 is 3/4. Oops, 3/4. And this one would be 4/8, or 1/2. Now, if we take a look across here, we use these ratios to keep them constant, and we just use the table that was given to us and what we knew already to help us figure out how many total pizzas were ordered. Now they want us to calculate how many total cups of meat would there be on 4 pizzas, 6 pizzas, and 9 pizzas. And if I do that, I end up finding, well, there's 1 cup for every pizza. So this one does have 4 cups. This one does have 6 cups. And this one does have 9 cups. Let's see if I have I don't have it. But basically, the lesson summary today is to find missing values in a ratio table where the total's given, you have to find the unit rate. Here, all of these were unit rates because they told us how much was used on one pizza. Once you know the unit rate, you can determine the unit rate from the ratio of the two given quantities and use it to find missing quantities in each equivalent ratio. Tomorrow we're going to go ahead and we're going to actually get started on the homework for this, but I wanted to make sure you at least had a good idea of how to calculate unit rates and equivalent ratios when you're given complex ratios in a ratio table. Thanks for listening. Great job.